Following on from the previous example, where the remedial actions schemes, or RAS, functionality was introduced, this video shows an example of multiple time phase contingency analysis with RAS. For any remedial action scheme, it is possible to assign times to the associated remedial action events. A non-zero time means that an action will not take place until some time after the RAS has been triggered. Let us consider the impact of a double circuit fault on the network voltage. Under steady-state conditions, the voltage at this substation is close to nominal. However, if this double circuit fault is executed, we can see that the voltage drops. Here we have a capacitor which could be tapped up to provide voltage support. The load flow settings do not include automatic tapping. For this exercise, the intention is to model the tapping at specific time intervals. The effect of this can be seen using multiple time phase contingency analysis. First, the analysis will be run without considering the RAS. If a voltage report is run, it is seen that the post-fault voltages remain low at all time phases. Now we will consider a RAS which has been created in order to tap the capacitor. Once the RAS has been triggered, the capacitor is tapped at the specified times. The analysis is run again and the effect of the capacitor can be seen in the report. To understand this in more detail, we can use the trace function to look at each step in the process. The first step is a base case load flow. The next step is time phase 1, at 1 minute. The fault case is executed and the voltages drop. This triggers the RAS, and so starts the timer for the events. The next step is time phase 2, at 2 minutes. The first event, timed at 30 seconds, has now been executed and we can see the resultant output from the capacitor. Over the next 3 time phases, the capacitor continues to tap, and the voltages on the network are increased. It should be noted that if single time phase is used, the event times are disregarded and all the tapping events will be executed.